Today we're going to look at function notation and evaluating functions. First we'll talk about what function notation is. So to write a rule in function notation, you use the symbol f of x in place of y, and you read this f of x. So if we were looking at these two examples down here, the first one says y equals 3x minus 8. The second one says f of x equals 3x minus 8. These mean the exact same thing. The only difference is when you use this notation, it's telling you that that is a function. That if you were to sketch that on the coordinate plane, it's going to be a linear function, which means that it passes the vertical line test because it is a function. Okay, so to evaluate a function, you're going to replace the variable, make sure you fill in your blank there. You're going to replace the variable with the number that's inside the function notation, and then you're just going to use your order of operations to simplify. So remember, when we have order operations, we're talking about our PEMDAS. So parentheses, exponents, remember multiplication and division are left to right, whatever happens to come first, and addition, subtraction, left to right, whatever happens to come first. Okay, so if we look at example 1, it says evaluate f of x equals 7x plus 4, and they want us to find f of 2. So the first thing that you'll notice here is that if we were to compare this f of x to this f of 2, notice what changed was the x became a 2. So we're going to take the equation they gave us, which is negative 7x plus 4, and wherever there's an x, we're going to fill in this 2. So we're going to say negative 7 times 2, since the x is right beside it, plus 4. So order operations, we're going to multiply first. Negative 7 times 2 is negative 14 plus 4. Negative 14 plus 4 is negative 10. Then you're going to write your answer as an order pair. So remember, in an order pair, it's always x and then y. Well, x is the number that you filled in for your x, which was this 2. Y is whatever your answer was once you plugged in that 2, which is negative 10. So this is our final answer here, 2 negative 10. But now, just to explain what that means, that's saying that if we were to draw negative 7x plus 4 on a graph, it's going to look something like that. It's a linear function. If we were to graph this point to negative 10, that's a point on that graph. That's what this answer, this solution, represents. So example 2, we have f of x equals x squared minus 2x. So this time, we're trying to find f of negative 5. So notice what changed. The x became a negative 5. So take the equation they gave us, which is x squared minus 2x, and plug in the negative 5 where the x is. So this becomes, notice I'm putting parentheses here, negative 5, the squared on the outside, minus 2 times negative 5. So order operations, we're going to do our exponents first. So negative 5 squared, negative 5 times negative 5 is positive 25. Negative 2 times negative 5 is positive 10. And then 25 plus 10 is 35. You write your answer as an order pair. It's x and then y. So x is what you filled in, which is negative 5. Y is whatever your final answer is, which is 35. This is your solution. So these are some U-tries, so it might be helpful to pause the video, try these on your own, then come back and watch the video and see if you had those correct. So if I look at example 1 here, or problem number 1, notice first off in the directions, it's giving you this function. Let g of x equals x squared minus 5x plus 2. So if you look at these examples, each one of these starts with g, which is how you know that you're using this function. So we're going to start with the first one, g of negative 1. So that means wherever the x is in this equation, we're going to replace with negative 1. So instead of x squared, we're going to have negative 1 squared minus 5. Instead of x, you're using negative 1 and then plus 2. So now it's an order operations problem. So negative 1 squared is positive 1. Negative 5 times negative 1 is positive 5. And then just bring down the plus 2. So now left to right, 1 plus 5 is 6, plus 2 is 8. So your order pair here is negative 1 for the x and 8 for the y. Now, if we look at the next one, we have g of negative 2. So this time, where that x is, we're going to replace it with negative 2. So negative 2 squared minus 5 times 2. Times negative 2 rather, and then plus 2. Order operations, negative 2 squared, negative 2 times negative 2 is positive 4. Negative 5 times negative 2 is positive 10. Bring down that plus 2. So 4 plus 10 is 14, plus 2 equals 16. So our solution here, our order pair is the x, which was negative 2, and our y is our answer, which is 16. All right, the next one's 0 though. So in place of that x, this time we're putting 0. So 0 squared minus 5 times 0 plus 2. So 0 squared is 0. 5 times 0 is 0. Bring down that plus 2. So 0 minus 0 plus 2 is just 2. Your order pair here, your x was 0. Your y is your answer, which is 2. Okay, one last one. This time we're looking at 5. So instead of the x, we're filling in 5. So we're going to have parentheses 5 squared minus 5 times 5, and then plus 2. Order operations, 5 squared is 25. Negative 5 times 5 is negative 25. Bring down that plus 2. 25 minus 25 is 0. Plus 2 equals 2. So this one also has an answer of 2. But our order pair is going to start with 5 since we plugged in 5 for the x. And then our answer is 2. So this time to find our answers, we're actually going to use the graph. So this time, instead of an equation, they give us this graph on the coordinate plane. So they give us this U shape, which is a parabola, which is a quadratic function. So if we look at the first one, it says that we want f of negative 3. Now remember what this represents. This negative 3 represents your x value, and what you're trying to find is the y value. So if we go on our x-axis to negative 3, it looks like we'll be right here. And notice at that point, it actually goes through that U shape. It goes through the graph at y is equal to 0. So our order pair here is negative 3 and then 0. The next one, we have f of 0. So once again, this number in here represents your x. So if I go on the x-axis to 0, I'm right there. But this time I'm going to have to go down before I touch the U shape. And if I go straight down from where I am, I touch the U shape right there. That y value looks like negative 9. So my order pair here is 0 and then negative 9. The next one's f of negative 1. So f of negative 1, so my x value is negative 1, which is right here. Once again, I'm going to have to go down to touch the U shape to right here, and that y value is negative 8. So my ordered pair is -1, -8. Okay, so last example here, example 4. This is going to be similar to example 3 where we're using the graph. So why don't you pause this, try these on your own, and then come back and see if you're doing it correctly. So the first one here is asking for f of 0. So once again, these are your x values, the numbers inside the parenthesis. That means you're going to go on your x-axis to 0, which is right here in the center. And notice you're already touching that blue curve. So your y value here is 0, which means your ordered pair is 0, 0. Okay, whereas the next one asks for f of 5. So once again, this is your x value. So go to 5 on your x-axis, which is right here. Once again, that touches the blue curve again. So that one's also 0. So this is 5, 0. Then we have one more, f of -2.5. So since it's negative, we're going to the left. So left 2.5, which puts us kind of right here between 2 and 3, or -2 and -3. But this time we would have to go down to touch the blue curve. So go straight down from there, which is right here. And that y value appears to be -4. So this ordered pair is -2.5 and -4.